In this model of an aqueous silver nitrate solution, the silver and nitrate ions are each surrounded by water molecules. The presence of the water molecules around the ions reduces the direct ionic charge interactions, allowing the hydrated ions to move randomly about the solution through collisions with solvent water molecules that are not shown. The positively charged silver ion is surrounded by water molecules in 3 dimensions. Since water molecules are polar, the partially negative end is attracted to the cation. In our animations, we'll be showing a 2-dimensional representation of the solvated ions to better see the ions. The negatively charged nitrate ion is surrounded by water molecules in 3 dimensions. Since water molecules are polar, the partially positive end is attracted to the polyatomic anion. In our animations, we'll be showing a 2-dimensional representation of the hydrated ions to better see the ions. When hydrated silver ions and chloride ions interact, there is a strong ionic attraction between the oppositely charged ions that overcomes the attraction that the ions had for the water molecules that hydrated them. The ionic bonds formed between the oppositely charged silver and chloride ions forms an aggregate that is insoluble in water. Please note that the water molecules shown disappearing after leaving the ions have actually become part of the solvent, which was not depicted. In this final segment, the silver chloride precipitate, represented by the 3D aggregate of ions, has formed. The spectator ions of hydrated sodium and nitrate ions are unaffected and continue moving about due to collisions with water molecules making up the solvent. Notice that the precipitate is actually made up of a lattice of alternating charged ions, and because of this, water molecules are still attracted to the outer layer of ions making up the precipitate.